Hello, today you and I will get to equate chemical equations using an unusual method. This is the method of mathematical equating, which is related to the selection of coefficients through mathematical patterns. At the same time, this method is usually studied already in higher educational institutions, so you can see for what level of students is required to be able to equate chemical equations using this method. So I suggest that we now deal with equating in this chemical reaction between potassium permanganate and hydrochloric acid. As you can see, I have written down all the initial substances and products of the reaction through chemical formulas. Now, what are the rules of equalization through such an unusual method of arrangement of coefficients? The first rule says it is necessary to put letters in front of each formula instead of numerical coefficients, which we will choose certainly by this method. And letters are put different in this case. So before the formula for potassium manganesu IV, I'll put the letter A. Before the formula for hydrochloric acid, I'll put the letter B. In front of manganese chloride 2, the letter C here, D here, E. And here, respectively, F. So you can see there are different letters in front of each of the formulas. Now we need to make what is called a mathematical expression for each chemical element. It will look like this. For the element potassium on the left-hand side, this is the left side we have in our interaction. A letter pattern denoted as A on the left side corresponds to potassium represented as D on the right side of the equation. Now on the left-hand side, we've got the next element, manganese. As we can see here, we've got A. And on the right-hand side, we have manganese. On the right-hand side is C. Then the next element is oxygen. On the left-hand side, we have 4 of them. And on the right-hand side, we have oxygen in the formulas. F, and in this case, we've got here F. Then the next element is hydrogen. Hydrogen on the left-hand side is B. On the right-hand side, we can see it's got 2 F's. So that leaves chlorine. On the left-hand side of it is B. On the right side of it, notice it goes into different substances. So in the formula, manganese chlorine 2 is 2. See? In the formula potassium, it's chlorine, it's D, and in the formula chlorine, it's 2 C's. And so we've written down the letter designation. Now let's see what we have to do next. Next, we have to solve some of the equations that will allow us to infer the coefficients. Let's see what we have here. This B that we see in this expression is related in turn to C. And let's see that C itself is equal to A. Then in our solution, we have in this expression the following. It's B, it goes like this. 2, see, is actually 2 A's. All right, D, let's take a look. That would be A. And then I can sign here A. The next one, we've got more. The usage of the word "and" in this letter is not consistent across all expressions. Thus, we observe this pattern and make use of this input to convert it accordingly. As a result, we end up with 3 occurrences of the letter A, plus 2. And now let's consider B, which is equal to 2 F's. Returning here, we have additional information for you. B is 2 Fs. What F represents is 4 A's, so I can input that here and it adds up to 8. And now, as we take a closer look, we find that there is one expression for pattern B and another expression for pattern B. By merging these equations, we obtain the resulting equations in this particular scenario. We have 8, and A equals 3, plus 2. And, or if we move it to the left side, that's 5A's equals 2S. And then for these numbers to match, A must take the value 2, and N must take the value of respectively 5. Now, then we can specify what our values in these expressions will be. And so if A, in this case, we have 2, our coefficients are determined as follows. For A, it is equal to 2, hence the coefficient is 2. Similarly, for manganese, it is also A, resulting in a coefficient of 2. The coefficient for oxygen is denoted as F, which necessitates determining the pattern for F. As for B, there is a coefficient which can be deduced by observing the pattern. Thus, it is revealed that the coefficients follow distinct patterns. We have B will have the value 3A's plus 2E's, or it would be 3 times 2. All right, so let's take a look at the situation. The N value is 5 and it's 2 times 5, which means that B is equal to 16. Consequently, it's 16 at this point. Additionally, as we have 2 Fs representing F such that F is half of 2 Fs, the total amount of oxygen is 8. So, with this in mind, we can now substitute our alphabetical characters. The coefficients on the numbers that we got, and so for potassium manganese O4, the coefficient will be 2. I'll even circle it now so that it's visible. H-chlor gives us the letter B, which corresponds to 16. So we'll put 16 here. For manganese chlorine 2, C is the same as A, so that's 2. D is the same as A, so that's 2 here too. Now the value being calculated is N, which is equivalent to 5. As a result, we will assign the value of 5 to it in this instance. And F is a value that equals 8, so we put 8 here. So we have the following equation: 2 potassium manganese O4 plus 16 H-chlor equals 2 Kali manganese chlorine. And now we're going to look at the same equation, but we're going to look for the coefficients in a slightly simpler way. Let's see how it's done. Let us endeavor to simplify this equation using an algebraic method. To render it simpler, let us introduce the variable coefficient A before potassium manganese O4. Now let us consider potassium. Since we have A before potassium, it logically follows that we must also place A before potassium chlorine. This is due to the fact that in both the left and right formulas, potassium is comprised of only one atom. Now let us focus on manganese. On the left side, it is likewise A. Consequently, before the formula manganese chlorine 2, we shall also allocate the coefficient A, proceeding to the next step. Next, we've got obviously chlorine, but the chlorine that's here, it's not in connection with the potassium manganese O4. Then we'll put it as B. Now we need to work out what factor to put in front of a chlorine and in front of water. Let's begin by discussing water. In the water formula, there are 4 A's placed in front of oxygen, which indicates that the number of oxygen atoms must be equal to that of the A's. Additionally, there must be 8 A's representing the resulting hydrogen atoms. By examining the letter patterns, we can observe that the expression becomes simpler as there are fewer letters involved. This simplification aids in finding the solution more easily. Similarly, we can consider the element potassium on the left and right sides, while for all other elements we focus on the left side, right side. And so on the left side we have potassium A, on the right side we have potassium A. Next we have manganese. On the left side we have A, on the right side we have A. Next we have the chemical element hydrogen. On the left side we have 8 A's. On the right side we have a total of 8 A's, which is the result of multiplying 4 A's by 2. The next oxygen on the left side of the oxygen, and on the right side also, and leaving chlorine. Chlorine is the one that will allow us to find the pattern. So on the left-hand side there's 8 A's, and now let's collect our chlorine on the right-hand side. So on the right-hand side it's 2 A's in the formula manganese chlorine 2, plus the chlorine that we have in potassium chlorine is also A. And there's 2 B's here. That's how many we have on the right-hand side of this element. Now let's see how we can deal with this expression here. So it turns out that we could simplify this expression. It turns out it would be 3 A's plus 2 B. But then we have an equation that has a left side and a right side connected. It goes like this. 8A equals 3A plus 2B. Let's move it to the left side. We get 5A equals 2. B. And then we can find our coefficients. Therefore, if A is equal to 2, the coefficient would be 2 as well. So then we have B for manganese, and that's also 2. Now let's consider hydrogen. Its atomic number is 8, so when we multiply 8 by 2, we get 16. For oxygen, the atomic number is also 8. Now let's focus on chlorine. If we substitute its coefficient, it will also be 16 on the left side. Therefore, the total number of chlorine atoms is the same as the total number of the other elements. So we substitute, so here we have a coefficient of 2. 8A, so that's 16. And here we get 2. We also acquire a pair here. In front of chlorine 2, this coefficient would be 5. And in front of H2O, we get a factor of 8. So our equation is 2 potassium manganese 4 plus 16 H chlor equals 2 manganese chlorine 2 plus 2 potassium chlorine plus 5 chlorine 2 plus 8 H2O. And look, the same method allows us to find the coefficients. It turns out we didn't work by selection, but through a mathematical pattern. This method is very suitable for difficult reaction equations, where it may or may not be possible to find the coefficients by selection. Then this method works well, but it is true that there are also situations quite difficult, when this method may not lead to the desired result. But nevertheless, we will practice equating such equations in the next lessons and practice again. But that's all for today. Goodbye.